and then it's almost like you can put everything on the table, but then there's this like deeper understanding of it that you can gain when you're someone like Einstein. And that's what he did with electromagnetism. He gave us this new, deeper, and just like this completely life-changing insight into electromagnetism with his special theory of relativity. So the fact that the speed of light is a constant in vacuum, it's a constant of nature. It's not just a trivial constant, oh, it can be changed. No, it's a constant of nature. So he talks about when we read the when we read the that was weird. When we read the book on Einstein's journey, with all this work, it's a book called Einstein's Cosmos by Michio Kaku. We actually covered that book here on the channel a while ago. When we read that, we saw that he was doing these thought experiments to imagine, like, basically racing with a beam of light, and he realized that even if your speed was very close to the speed of light, like say you're going at point, so say speed of light in vacuum is a constant of nature. So say that is c. Oftentimes in physics, we just call it c. Even if you're going at 0.9 c, you would still experience c to be the speed of light. So that actually changes everything, turns out, because from there we get the relative nature of space and time. So space and time, space-time, it's a four-dimensional space-time. Basically, space-time has the three spatial dimensions and the one time dimension. So first of all, being comfortable with this four-dimensional type of understanding is good, because that's basically space-time. But the fact is that because of the speed of light being a constant of nature, space-time becomes relative, and there's length contraction and time dilation. And not only that, we also have mass and energy equivalence. E equals mc squared. All those, the famous equation comes from that. So that's where I think this comment, that's good. And I just wanted to tack on this particular piece, which is that the speed of light being a constant of nature in vacuum, and yes, other things with mass more than a mass of zero cannot have that speed. If you have doubt about this, and you are interested in the time travel and the space sci-fi type of stuff, you could special theory of relativity is the thing that you need to read about. It'll be really interesting and hopefully clarifies all of that. And also, we did talk about a wormhole example from the same book that I think it was Kip Thorne who came up with that. So it's not like that the topic of it's not that we didn't consider time travel at all on this channel. We do talk about it sometimes. I'm not into mass times energy is equal to mass times E equals mc squared. Yes, indeed. Thank you. Hello, Renee. Such a mesmerizing, you make me feel at peace. Awesome. The secret to originality is to hide your sources well. Oh, wow. Is that what he said? Let me go back down. But yeah, thank you for the comments about the speed of light. That prompted me to talk about special theory of relativity, which of course gives us the updated theory of electromagnetism. Granted that electromagnetism, of course, was contributed to greatly by some of the fathers of it, such as Michael Faraday and Maxwell and other people, Gauss and people like that. But bringing it all together and adding that extra, extra, extra